anything so far on lecture 1 or in tutorial class. So till now, if anyone is having any doubt, they can ask. No? Okay. So this overflow and all these things clear. Okay.
Sir?
Yes.
Sir, the practice, can we ask doubts related to practice problems in practice set 3?
Yes, you can.
Sir, can you explain how to solve this Euler-Stoshian problem? I know the mathematical concept, but I am not able to write the code. I know the general formula of it.
Okay, so
Euler-Stoshian.
for this, you want to know the logic flow or how to write the code for this Euler-Stoshian, right?
Yes, so the mathematics I know, but how to write the code that I am not getting.
Okay, so in this tutorial, it won't be possible. I guess I will text you in WhatsApp.
Okay, sir. Okay, sir.
Actually, I've forgotten. I've told that I will explain, but I've forgotten. Clear that out. But okay, I will clear it. In greater problem, yes. So if after this, so let me cover few concepts. If you have doubt related to concept like tutorial or the lecture, you can ask here. Or if we have time and I've covered the concepts, then we can take like this practice problem and lab problem questions or doubt at the end. Okay. So, okay. So has anyone tried with this math.h how to compile a code? So let's say I've written this this thing. Let me delete the previous. Okay, I've written this power function, which is power. So it will give me 2 to the power 2, which is 4. So let me compile it. So I will do GCC program.c. Okay, so it worked. Okay. Works in this apply SQRT of GCC. Okay. Actually, there are few functions in math.h. So to compile this thing using, so to compile that, in that case, what we have to do, we have to write something like GCC program.c, and then we have to link this math library using this -lm tag. But I don't know why it is working here. Maybe the compiler is advanced or something like that. But to compile anything that is coming from this math.h, you have to include this -lm tag. Okay. Otherwise, it will throw error that the point that you are referring the function is not kind of linked. So it is runtime error. Not runtime, it is compile time error. So let me write a function sqrt pav. It should throw error, but it is not throwing. Okay. Maybe the compiler is advanced, but nonetheless, in general, we do something like this. If we include this math library, and then we write this a.out to print or run the program whatever we have written. Okay. So this was like extra thing. Kuldeep Kumar. Let me, in previous class, you have seen that there are some limits like int min, int max. So where those macro is defined. So there is this file limits.h. So there is this file limits.h. It defines many macro. What are those? So int min, int max. Okay. Then it also have u int min. Similarly, u int max. Then it have for long. It have long min, and long max. And similar to unsigned, it will have for unsigned long. So let me just print those values. So u long max. Okay, let me print this value so that you can see. Percentage d, percentage b. So int min, int max, and then u int min and u int max. Okay. So I guess u int min is not defined. Only u int max is there. So when I say int min, it will have the least possible value that an integer data type can have. So when we define something like int y, the y can take a value between this int min and int max. Okay. So if you print this int min and then int max, then you will see those values. And these values are like system dependent, because in some system, like in 32-bit, 64-bit, or in other architecture, so you can have like an integer can take storage up to 2 byte or 4 byte or 1 byte. So in those cases, as you have seen that when we have more storage, we can store more values. When we have less storage, we can store, the range will be less. So this can vary system by system, the value of this int min and int max. Similarly, this unsigned max. So what is this unsigned thing? So I've told you, you can declare something like this. So when you write unsigned, what it does not consider this negative values. So when you write this int, by default, every integer is signed. Every data type is kind of signed. It can have positive value as well as negative value. But when you add unsigned to it, then the value of this u would be 0 to whatever the maximum positive value that this unsigned int is pointing to. So this is the unsigned max. Okay. So that will be the maximum value an unsigned int can have. And similarly, it can vary from system to system due to this storage thing. Any doubt?
Sir, you mean if we enter -3?
Yes.
And then if we printf u, then we will get 0 instead of -3.
Okay, we will see definitely. We will see what will be the value. Okay, it will be kind of truncated or something like that. There will be overflow because you are going below 0. So there will be kind of underflow or overflow. And what will be the value? Is it garbage or is it like same value for every time we run the program? We will see. Okay, after this. That is a nice question. Sir. Yeah. So let's try to see what is this int min, int max, and what is this unsigned max. And let's see the behavior of this signed and unsigned data type. Through.
Okay. So I think so. So the unsigned int min is actually because of we know it, right? Because it is always going to be 0. That's why it's not been defined.
Unsigned min, yes, that's why it is not defined. Yeah. Similar thing for unsigned long, I guess. For long as well, you don't have this thing. So when you can something you can refer implicitly, then you don't define it. Like remember the cast type casting thing. Like when you go to higher to lower to higher, you don't typecast. By default, it is kind of implicit. But when you go from higher, like when you cast a float to integer, then you have to explicitly mention int there. So these are the thing when things can be defined like implicitly, then you don't have to write it explicitly. So when you consider this unsigned, then obviously the value 0 will be the minimum thing. That's correct. Yeah. So let's see the output. Int max is -1. Okay. Why it is giving -1, by the way? Anyone? Anyone? Why it is giving -1? No.
Like we can't see your screen, sir. We're seeing your ad block has been updated.
Oh yeah, yes. Yes. So why it is giving -1? Uint max.
Sir, can you again show what was the input?
Yes, sir.
There is a no input, right? This is the code. Can you see the code? It
Yes,
is
sir.
a
We
5-line
aren't
code.
taking anything from the user. So how can we
Right.
expect anything?
What? You are printing something, right? You are using this printf. So it will show some output, right?
Yes, sir. Yes.
When I run this code, how can you say that if you're not taking anything from the user, you cannot show anything? See, you have not taken anything from the user, still you are getting the output, right?
Yes, sir. Yes.
Yes. So why this? I will discuss what is int min, int max, what is the value, but why this uint max is giving like -1?
Sir, unsigned integer value have always have positive value. So by default, we are taking the max value to be -1.
What can you repeat?
So the uint max will, if we scan anything, will always give a positive value.
It is not scanning anything, it is just printing.
Yes, I mean in that way. If we scan, it will be unsigned value, so it will give positive value. But since we are not scanning the default value of uint max, that is -1, it is scanned to be printed.
No. This uint max is kind of defined. It is exact a particular value. You can compare whatever you have taken with uint max. So these are like defined constant. So when I say there is this directive, so this is called has include directive. There is other called define, and using this you can say, okay, this int min, let me define it as 23 or -23. Okay, so wherever you use this int min symbol, it will replace int min with -23, right? So that's why I've said that this limits.h defines some macro. This is called macro. This int min, int max, uint max, you can see it is not defined anywhere. Actually, it is not like a variable because everything is capitalized kind of thing. So this is a macro which is defined in limits.h, and it has some value. So in the compiler stage, this will be replaced with whatever value that is having. So let me write a simple thing so that you can understand. So there are various stages in the compilation. So when I write define name as 10, okay, so wherever you write this name, printf %t and then name, okay. So what will happen here? There is a pre-processing stage in the compiler. So in the pre-processing, whatever comment that you have written, it will be eliminated. Whatever new line you have entered, so whatever syntax, indentation, beautification that you have done, everything will be eliminated. And this files that you have written has include limits.h, it will be kind of copy pasted here. And then whatever you have written, something like has defined name is equals name as 10. So this is a kind of the signature of has defined would be has defined. Okay. And then symbol that you want to define. Okay. Symbol that you want to define, and then the value that you want to assign. So you can assign here string, you can assign here character, you can assign here integer, you can assign anything. Okay. So what will happen? It will just replace this name with 10 wherever it sees this name. So in the pre-processing stage, every comment will be eliminated and this name will be eliminated, and then 10 will be there. Okay. So ultimately it is same like I'm printing 10, but not like this. I'm printing like this. When you run this program, you will see that 10 will be printed, right? So in similar fashion, there is this limits.h. It defines few macro. This is called macro. Int min, int max, uint max. Okay. So
Could you please explain define name once more? Could you just explain that? So could you just explain the last define name once more? Like define name part, which you just hash define that part.
Yes. So this hash define. Okay. So it is a kind of macro definition. So when you write hash define, it is called how to define a macro. This is called macro. Whatever you symbol you write, this is called macro.
So and then macro, like otherwise, like I've heard macro variables once, but like is it so like it's like a analogous to a variable?
No, it does not store variable. It is just like kind of replacing. So I can elaborate when this will be there in lecture, maybe in last lecture, maybe in last module or something like that. But for now, just assume that there is this hash defined thing similar to hash include. So it is kind of telling the compiler that please include this file stdio.h. What does it mean? It copies whatever thing is written in the stdio.h to this file. Okay. And it is done in, so there are kind of 5 or 6 stages in a compilation process. So this is in the pre-processing stage, that is the first stage. In that, this thing happen. So it will include this stdio.h, copy paste thing will happen. Then whenever it find hash defined, it will replace. Here there is a only replacement. There is a no checking, no type checking, nothing will happen. So whatever the symbol, the macro that you have written here, here I've written, for example, name. So whenever this entire file will be scanned, and whenever this name will be encountered, it will be replaced by 10. So what will happen? So it will be replaced by 10.
So,
okay.
So say if I put a character.
So you can yeah. So in competitive coding, what happens? Time is like very precious thing. So what happens? You write like this. Unsigned long. ULL is defined like this. So you don't have to type unsigned long many times. Just write ULL and U, okay, or T. So in competitive coding, you have this time limit, and you're typing. So if you type like a multiple thing, this unsigned long multiple times, instead of it, you can use ULL as a kind of shorthand. So this is how this hash define or the macro is used in real thing. There are many other things also like looping and many things, but for now just keep it simple.
So yeah, it's just one thing. It's just being replaced. It's not like a storage, like a variable.
No, it's not like variable. No,
it's like a one-time use.
One-time use, yes.
Okay.
In the pre-processing, it just replaces whatever the value that it's written. So it's just one-time thing.
Okay.
Yeah. It does not store anything. It does not take any memory or something like that. That is why it is called macro. I don't know why the word macro is used here, but yeah, maybe I'll find somewhere. So this name will be replaced with 10. So that is why when I printed this name, it is printing 10. Okay. So in similar way, this limits.h define few macro, int min, int max, uint max. Okay. So when I executed the program, it is printing this int min, which is the minimum value, and it should be some minus because we know it is kind of signed, so it will include the number. And then this is the maximum value that an integer can have, and it is kind of it can vary from system to system, like 32-bit, 64-bit, 128-bit. So the more storage an integer can have, the more range you will see here, the value of this range. But my question was, like this uint max, why it is giving -1? It should give some maximum value, like this int max is giving, right? Why it is giving -1?
So because I think so limits.h is not included, right, sir?
It is included. Limits.h is there, right?
Okay. Okay.
Think very simple. Very simple. See the printf at line number 13.
So I think so. Is it because of the D? Because unsigned will have a different D. Instead of D, will have something else.
Right. There is a overflow. So this unsigned max will have definitely the larger this maximum value than this int max. That is obvious. Why? Because it is a kind of sign. It start from minus to plus, but this unsigned thing will start from 0 to some maximum value, and it is a kind of this percentage D cannot hold this unsigned max. So that is why it is giving overflow. If I use percentage U, which is used for unsigned, it will give the exact or the correct value. Or you can use percentage LU here or percentage R. As you can see, this maximum, which is int max, and this unsigned int maximum, this value is kind of double of this plus 1. This value here, this value 95, this 42, 95, it is a double of whatever int max is. Not just double, it is a double plus 1, right? Why so? Anyone?
Because we start from 0 instead of starting from some negative that.
Yes. So like when you start from minus to 0 to again plus, so you have seen from the this integer encoding, there are like kind of n/2 plus 1 patterns or reserved for negative numbers in case of signed. But in case of unsigned, there is no negative number, so you will have n/2 plus 1 more pattern to include this positive number. So that is why this is n/2 plus 1 more than this thing. So this is kind of 2 times plus 1 of whatever this inference is. Okay. So that is the reason behind it. So similar thing goes for long min, long max, unsigned long max. Okay. So that is about limits.h. There are other macro as well, but these are like more frequent. People use it more frequently. Any doubt so far?
So I forgot what is limits.h used for, so I just forgot.
So limits.h defines these macro.
It defines them. Okay.
Yes. So remember, I've written like this now.
Yes.
So where was that? So I've written some macro definition here, right? So if it was .h file, and those macro kind of defined here in this .h file, and I can include that .h file to whatever file I want to include, right? So similarly, this limits.h define all this macro, int min, int max, to int max, and all this. There are others also like character, signed, and other, but these are like more frequent, and these are kind of more useful than others. Okay. So any doubt? So Divyanshi Bansal, you have joined like this much late, or is it like second time or third time? Divyanshi, can you hear me? No? Divyanshi, can you hear me? Okay. So any doubt in this limits.h? No. Okay.
So we require UL only, right? Instead of D, that's it.
Yes, instead of D. So when you want to print some unsigned, so you write %u.
Okay.
But like in case of this long min, you have to write %l. Similarly, for long max, you have to write %l. For u long min, there won't be any u long min because we know that it will be start from 0. That is implicit. Now u long max. So how to print u long max? For that, you have to use this printf with %lu. So let me print it. Printf %lu and this u long max. Okay.
And so for long min,
There won't be any. So you can see the maximum value here. For long min, you have %l. For long data type, there is a %l, right?
percentage?
%l, this L.
Okay. Okay.
Yeah. So when you define some data type like long I, you can print it using %l. This %l has to be passed to this printf to print it. Okay. Now coming back to the question that if we assign this -4 and we try to print this u, what will happen? So what will happen? Anyone? In this case, what will be the output here?
So wouldn't it be an error?
There won't be any error, right? Because this unsigned int is kind of having higher storage, and this -4 is kind of integer, which is having less storage or less range. So you can go from, you can implicitly typecast it, right? So there will be typecasting, and whatever this, so due to this typecasting, there would be overflow kind of scenario, and in that case, you will see something. So when you print it with %u, you will see some unsigned thing because %u is used. But if you use this %d, let's see what will be the output. -4 is the output. Why in case of %d, why it was -4?
Because there's no overflow or underflow.
So -4 is kind of, remember this character, this encoding. So if we in 32-bit system, if we write -4, there will, it will start from 1 because the first most significant bit will denote this minus thing, whether it is minus or plus, and then there will be a lot of 0 because it is a kind of 32-bit, and then last 3-bit would be 100, which will indicate the value 4. Okay. Now when you write this when you printed using %d of this u, this entire thing would be converted like it will be, this entire thing would be treated like some combination from this integer range. So it was correctly printing this percentage, this -4. But if we write, if we have printed it like %u, right? So this entire pattern, whatever we have written, this entire pattern would be treated as a unsigned, some unsigned this bit pattern. Here the one won't be treated as a -1 sign. It will be, this entire thing would be treated as a kind of this unsigned pattern. And in that case, you have seen that in case of %u, we are seeing this output. Okay, but in case of %d, we are seeing -4 output. Okay, so that is why we are seeing different output by %d and then %u. There is a type conversion, and this entire thing would be converted to either this signed integer or unsigned integer, depending on whatever you are passing here, whether you are passing %u or %d. So this this encoding comes into picture here. Okay, the doubt is clear.
Yes, sir. Yes, sir.
So let me discuss another topic, which is a scope. So what is a variable scope? So when we write this in type,
Sir?
Yeah.
Sir, a general doubt. Sir, these topics that you are covering, will that be asked in the quiz? Because in lab, they are asking the concept that they ask in the practice problems. So these
it
questions.
can be used in the quiz. It can be used in the lab as well. In
It's a
this
lab also.
lab. Yeah.
Okay, sir.
Yes.
Because of this theoretical question, that's how I was thinking, how will they ask in the labs? But they can ask in quiz.
Yeah. So whatever topic we have covered, we can mix like the concept in any way. Right.
Okay, sir.
Yeah. So before scope, let me cover this function. Then I will cover this scope. So how a function is defined. So that the signature of a function definition is like this: return type, and then function name, and then it will have type, argument 1, type, argument 2, and similarly others. Right. This is called a function declaration. Here you are not defining what this function is going to do. So you can define a function like, let me return int and let me calculate sum, and then it will take two values, x and y, and then this is the thing. Now this is called declaration. Okay, this is general prototype. So this is called declaration, and then we can define this int sum somewhere, int x, int y, and then return x plus 1. Okay. So here, and how to call it? So let's say I've taken xy, I've declared this xy here, and I've taken input from the user. Or let me just write it like this. Okay, and then I'm printing this %d. You can use percentage because it is an integer, and then you can print sum of x, y. So that is how you call a function. You call the function with function name and pass the argument. So if the argument is, the number of arguments should be same, and the type should be matching. Like if I've declared the x here as an integer, the first argument should be integer. If it is a float, then it will throw error. If it is a character, then it will implicitly typecast, and then the ASCII value will be converted here. So those things will be there, right? So this is how you call a function. So let me print it.
Sir.
Yeah.
So the declaration like that, does that have to be like if we declare it before and like we have to declare it inside the function itself, right? Like it's a local declaration.
Yeah, it is. So let me cover those things, and then you can ask question. Okay. So I will cover whatever you're going to ask. Let me cover those things, and then let's see whether I cleared your doubt or not. Okay.
Yes.
So let's wait for a few seconds or a few minutes. So you can see the sum is printed, which is 157. Now we can write this sum, the declaration and definition together, and from here we can use this return x plus y, and then we can remove this x, whatever we have written here, right? So that is also a possibility. But if we do not define it here, okay, then what is going to happen? In C, everything start from top to bottom. Okay, so parsing will start from top to bottom. Now it has kind of stored that, okay, xy will be variable, so xy is referenced here, so it won't be having any problem. Now it is going to scan this thing. Now it has found that there is this sum, which is a function. Now that function it has not found so far. From line number 1 to 13, it have not found that there is a function sum which is going to take this to value. So it will throw error, that kind of undefined reference or something like that. Okay. So currently it is throwing this implicit declaration of function sum because you've not defined it. It has not found it. So you have defined here. So in case of top to bottom parsing, which is a kind of C thing. So C does this top to bottom. So you can see that if I go from line number 1 to 13, I've not found anything which is a kind of similar to this sum function. Okay, that is why I've written a prototype. So I've declared that there will be a function sum, and this space is kind of optional. You can put it, you cannot put it. Okay, here same thing. So this space is optional, but this comma is not optional. You cannot have it like this. Okay, this comma is like mandatory. So it's separate to argument. So this is called function definition. So that is why we have kind of defined and told compiler, okay, there would be a function sum that will be called, and then it won't throw an error, and then accordingly this sum would be called wherever it is defined. That is why in mat.h there are functions of sqrt. We have included those header files, and we are able to call this pav or sqrt functions from the main. So this main is called this main is calling this function sum. Okay, with 2 argument, and you can pass like multiple argument here, I, j, k, but you have to change the prototype as well. Okay, so what happens in .h file? So in .c file we do actual definition or computation. In .h file, which is kind of header file, we define most of the variable or the function or any structure, such that if we include this .h file and we are going to call it during parsing, it will not throw any error. So there are, as I've told, that there are stages in the compilation. So after pre-processing, there would be parsing. So it will go from top to bottom, line by line. As soon as I open it, then I have to restart. Okay. So yeah, any confusion in this function? How to define it, how to declare it?
Like that int in the starting, like return type. Like if we had float, then like what would we can?
Yes,
do
you
float
can.
also.
You can write float here.
Then in
And
this,
then
like,
you have to
main
use
wala
this
function.
%f, right? And this thing should also be changed, like it will return float, right? And then you can take float values as well. As we have seen that the pow function is taking double as an argument and then returning double as well. Okay, so you can write this float. Remember the question that why this
Yes.
mat.h many functions have double type, why it cannot have integer or float, because of those things. So if you remember that question, then it's kind of clear. Similar to float, you can assign this void, which is not returning anything. So when you write this void, so let me write how this void look like. So let me write a function called display. Let's say it is called like that, and it just display something. Okay. So when you call this display here, you cannot call from here because it is not returning anything. So it might throw error. So let me see whether it is throwing error or not. Yes. Since it is returning void, which means that it is not returning anything. So
But we had
you
that.
have to use it like this. Yeah.
We had that %d, right? Like that's what was creating the problem.
Yeah, because yes, that's correct. Okay. Sorry. Yeah. So that is how you write a function which does not return anything. Sometimes you want to have those functions, and then you can have a function which return kind of integer, float, character. It can return pointer as well. So which is a kind of returning it as an array. So when I cover this pointer, then I will discuss how it can return an entire array instead of one value. So you can see that when I call this sum, okay, and I've called this sum, it is just returning one value here, right? This is kind of single value. If I want to return multiple values like array, in that case, how to return it? So for that thing, the pointer needs to be covered. So after covering pointer, I will discuss again how to return a pointer and how to manipulate or how to work with pointers. Okay. So that is about function now. So any doubt in this function thing?
Like void was for just like if you wanted to display simply display something like
Not just
if it
display,
doesn't
you
have
can,
any particular data type.
you can have data type. I mean, if you do not want to return anything, you mention it as a void. That's a simple definition of void.
So it can take
If you want to return
arbitrary type.
something, so if you want to return something, then please mention the data type, the return type. If you do not want to return anything, okay, in that case, you declare the return type of a function as a void. Okay.
Yes, I got it.
So let's say in a big software, you want to initialize few variables, few global variables. just at the launch of the software, you want to initialize something. So you may not want to return anything from that function. You just want to initialize. In that case, you can make it as a void, and then it can take like argument. It cannot take an argument. It can take a variable number of argument or the static number of argument that I will cover. But for now, just consider that there would be a static number of argument. Static in the sense, if I've declared a function like int x, int y, then it can only take it will exactly take 2 number of argument. It cannot take 1. If you write this sum this x, it will throw error. This thing will throw error. Like the definition won't be matched or something like, yeah, too few argument. Okay.
So then what is this main doing, like this int main that we have, the main function?
Yeah, so in the main function, it is a kind of entry point. So how compiler know where to start? So this is an entry point, int main.
Okay,
It
like
tell the
when
compiler, please start from here. Whatever written, start from here. So this is a function, which is a main function. Main you can see from the word itself that this will be executed first, whatever written inside this main. Okay.
But then like, how will it read the functions? If it's not inside main?
Who read the function?
So like the compiler.
Oh, if it is not inside the main. So yeah, you have seen that there is this printf function, right? It's not inside the main. So how it is reading it? How it is getting the definition of this printf?
Printf is from the stdioh, right?
Right. So when you have written this hash include stdio.h, it will copy paste whatever written in the stdio.h, and in stdio.h there will be a declaration like printf and then number of argument, type, all this thing, and something like this. Okay.
Yes.
Yeah. So that thing will be copy pasted here. And since you have found this printf here due to this copy pasting, so you won't produce any error because printf is there, right?
Yes, I got it.
Is this clear, your doubt? Okay. So that is about simple function, not complete. So when I cover this pointer, I will, and one more thing, you can pass variable number of argument, doing something like this thing, 3 dots. I will discuss about it. So if you declare a function like this, so you can have at least 2 argument. So you can pass 3, you can pass 4, you can pass any number of argument. A live example would be this printf, right? In printf, we pass a string, some string, okay? And then if we pass the variable number of argument. You can pass 1, you can pass 2, you can pass 3. So how it is written? It is written like that, using this 3 dot. So it tells compiler that it can take variable number of argument, but at least 2. So in printf, it would be something like this. Printf, and then there would be a string, like star format, and then there would be this thing. So in printf, you have to pass at least 1 argument, and the rest thing can be a variable. So that is how printf is defined. Since pointer is not covered, so I will not discuss it, but yeah, that is how printf is defined. So I've declared this printf as an int. Why int? Because what it will return. So when you call this print, so let me show what it returns. Printf returns something. It is not a void function. So Can someone someone tell what is the output of this thing? Sir, how do we get a void function executed? Like in Python, we can just write the function name and input to execute the function. So how do we do it in C for void type function? It is the same. So like you can call this, so you can declare a function void sum, and the same way you are calling sum from here, you can call the same thing. Like you can call, let's say there is a display function, which is a kind of void. So you can call a function like this. And then the number of argument that you might be having, you can pass it here. Okay, so same way. Okay, so can someone tell whether what will the output of this printf? No. Okay. So first, this printf will be executed. It will print ESC. So it will have 1, 2, 3, 4. So by default, so printf return whatever character, the number of character it has printed. So it will print ESC/n 4/n. So let me print it. Okay. So this ESC new line is printed from the inner printf, and then 4 and /n is printed from the outer printf. So printf return whatever the number of character that it has printed on the screen.
I didn't understand what
this is like the len function in Python. I don't have heard the len function. What does it do? So what does it do? Yeah.
It gives the length of a string, like any list or string or dictionary.
So it is returning something. So it won't be a void, right? The return type of this length function should not be void. It should be some integer, right? Because this Python thing is like very bad way of programming, but very comfortable. So this Python does not, in Python, you don't have to mention any return type because it is not kind of a strict type checking language. But in C, if you want to write a function which return length of a string, then you have to have a return type as an integer, int, because it is returning something. Okay. Here. Yeah, someone is asking something in printf.
Sir,
No?
I didn't understand like
Yeah.
how the output for this.
Okay. So when you write a printf like this, what happens? First, so when you tell the execution flow of this printf written as line number 16,
like it will just print, like it will compute x plus y and then print.
First it will compute the x plus y. This is the argument, right? So first it will do the computation. In similar way, first it will do whatever is written here. So argument is not like, it is a function, right?
Yes.
So first it will call that function, and that function is printf. So it will print that thing and printf return something. So you have seen that I've written sum of x and y, right? And I've printed it. So how it does? First it call this sum and values returned here, and then this printf is called.
Oh, right. Understood.
Yeah. So in same way, like you have seen in the x plus y. So first x plus y is computed, then this printf is called with %d. In same fashion, this printf is kind of executed. So ESC will be printed. It will return number of character that it has printed. So it will return 4 because ESC/n would be 4, and then 4 will be printed here. Okay.
Okay. Yes, sir. Yes, sir.
Yeah. So any doubt?
So like
No?
Can you show the output?
Yeah. So where was you when I was showing the output? Yeah. Is it visible?
Yes, sir. Yes.
Yeah, this is ESC4. Okay.
So like a value of printf is number of like element.
Number of characters that it has printed on the
Printed.
screen. Yeah.
So like what will be okay then percentage d like of some integer that will be 1, like percentage d will be counted as 1, right?
Percentage D will be counted as
Percentage d comma like some integer, like, then that will be 1. Yes sir, understood. Yes, sir.
yes. So when you no, it won't be 1.
Or it will be the number of letters in that integer.
Yeah, right.
Number of characters in that integer. Like 1, 2, 3, then that means it will be 3.
Right. If you write like this, so let me write it like this. Okay.
It will be
So
3.
in that case, it would be 4 because /n is there also, right?
4. Yeah.
So let me remove this /n, then you will see the. This would be +1. So 8. This is 3, 3, 6, 7. So 8.
Yeah.
Okay. Yeah.
Yes, sir.
So yes, no doubt in printf. Okay. So let me define this sum as well as declare it and cover what is scope of a variable. Return x plus y. Okay. Now I've written this same variable x plus y in main function, and the same variable I've written here, right? So it is kind of said that this x plus y is local to this main, and this x plus y is local to this sum. Okay, how? So if I write this x, if I change it, okay. Now if this x and y is local to sum, and this xy is local to main, then if I change something in this sum function, it should not be reflected here, right? Because both variable, the name is same, but the scope is different. So if I print this sum x comma y, let me take simpler numbers, 1 and 2, and then I print x plus y, and let me change it here 3. So what will be the output? What will be the output?
Don't we need a percentage d as well? One more, like.
Yes. Yes. So what will be the output here?
4, 3. 4 and then 3.
Right. 4 and 3. So you have seen that the x and y value is 2 and 1. It is changed in sum. But since x and y is local to this sum function, it will not reflect here. Okay. But this is called local scope. There is a global scope as well. Int x equals to 4. So I've declared x as a global variable. Now let me not pass this x because it is a global, so it will be visible to everyone. Now, since it is global, so whatever changes that are made here, it will be visible here. So let me show you. Four and 3 is the output. So I've made this x 2 and 1. I've passed this sum y. Now 3 plus 1 would be 4. and then since sum is 3, okay, let me change this. What was the output? 4 and 3, sum of y. So x was there, so x plus y 4. Now x is 3, y is 1. It should be 4 and 4.
You defined int outside, right?
Okay. So, yeah. And now I will come to that point why it was giving that thing. Again the same.
So like it is
Have I
outside
declared this
main.
x?
Like, is it meant to be outside main, like int of x equal to 4?
Yeah, it is outside of main, right? Int x is equals to 4. Int y, this sum y is giving this 3 plus 1, which is 4. Now x is modified to 3, so it should be giving 3 plus 4, right? 6 here. Is it still true? Okay. There is this associativity things coming into picture. Yeah. Okay. Someone else is executing before something else. Four and 4. Okay. What is happening? In case of sum of y, the x is modified. So first thing that a compiler do, it is start from line number 1. It has initialized the variable x as 4, and kind of remember that it is a global variable, so it will be visible to everyone. Now it goes to main and then start executing. So x is initialized to 2, again change, not initialized, change to 2, y change to 1, y is initialized to 1. Now when you pass this y, x is changed to 3, so it is giving 4. Now again you use this printf, since x is changed to 3 in this sum, and since x is a global variable, so when you do 3 plus 1, it is 4. That is how this global variable comes into picture. So when you want to reflect the progress of a function from the multiple function, then you declare it as a global. Most of the time we avoid it, the global declaration of variable, but it is a kind of sometime compulsory to have it. But most of the time we avoid it because it had a lot of confusion here. But in previous thing, white was printing 4 and 3. In this thing, it was printing 4 and 3. Why? Because this x plus y is executed first. So there is this right to left kind of associative of this printf. So this x and y is executing first. Since sum is not called, so x is 2, y is 1, so it is giving 3. Now sum is called, x is changed, but since after this I'm not computing any x plus y, so after this sum function, if I write this x plus y, then that value that I've assigned as 3 will be reflected. So due to this associativity, you have not seen the 4. Now you can see the 4 here. Yeah, someone is having any doubt? Some doubt.
So like whatever is the most recent value, it will take that.
Yes. In case of global.
But in Python, like there is a like global variable means like if you define it somewhere outside, then it becomes global. Here it essentially it's confined.
If you declare anything, yeah. If you declare any variable, even you can declare some variable in stdio.h and you can use it here. But for that, there is a keyword extern. sorry, external. So here it will not declare int and in its make it 4. It will see those header files, and if there is this integer x defined somewhere in those header files, then it will make it that global variable as 4. But if you do not write this extern here, it will make this x as a global variable.
So like, won't that break the header file?
Won't that break the, which kind of
Like
breaking?
you're setting all the values of x in the header file as 4, right?
Yeah.
Like then, like, okay, I mean that's specific. Like, okay,
I mean, that is why this global thing is avoided, because you can do many silly things if you're not aware.
okay, yes sir, yes sir.
Yeah. So this is a global, and now if I do in previous example as well, you have seen that I've declared this x here. Okay. So which x will be kind of having the precedence here, since there is a x which is a global, so it will be visible to everyone, and there is this x which is a local to this main function, and you have initialized a value 2 here. So what is the precedence? Who is taking the precedence? So here the local variable is taking the precedence, so value 2 will be assigned to this local variable. This x is equals to 2. It will not be assigned to the global variable. How to check it? If you, okay, let me, yeah, it is returning, so it is okay. So I've assigned here x as 2, y as 1. Now I've called some y. So x is assigned 2. If this x is assigned as 2, then sum would be 3. If that x is not assigned as 2, then sum would be 5. And similarly, the x plus y would be 3. So let's run the program and see the output. Yeah, 5 and 3. So you can see when I assign this x is equals to 2, it is a assigning local variable, not global variable, because there is a local variable. So when there is a local variable with the same name of global variable, then this local variable is kind of will have higher precedence. Okay. So this is how scope is getting into picture. Any doubt in this? How this local variable is having higher precedence than this global? Okay. So this is global, this is local. Okay. Now there is this block scope as well. What is that? So you can write something like this. Next. Okay. Now use the same %t in this also. So what will happen here? Anyone? What will be the output here?
Only, right? Both of them will be 2 because both of them are inside the main function, main part.
Yeah, so let's run it.
Oh, they're separate. Okay, yeah, fine.
Now this x is global variable. Okay, so when you have printed this x, as I've told you, if there will be a local copy of that global variable with same name, then that will be having higher precedence. So this as x is assigned to, this is local. So printf will take this x instead of that global x because x is there. And then this printf, since there is a no x here in this block, so it is a kind of called block scope. So this x is live from line number 18 to 20. It will die after line number 20. When line number 20 is executed, it will die. Die in the sense that storage is freed. There is no local x now. So then line number 22 will start. So it will give another scope. Now since x is not here, so it will use global because there is a global x. But if we have declared some x here as 9, and then this x will be having the higher precedence than global. So you will see that as output 2 and 9. Okay, so this is called block scope. So this, the value of x as 9 will lie from 29 to 24. After line number 24, it will be kind of dead. There won't be any x, any local x. So with this curly braces, you can have a block space, block scope. Even if you see this main, this is a curly brace. So in main as well, you have declared some variable with the same name as global variable. So in that case also, I've told that it is called local variable. So in case of local variable having same name as global variable, the local variable is having the higher precedence. Similarly, in case of block scope, so if I define, I can nest it like this also. If I write like this, then again, there is this local variable to this function main. The lifetime of this variable is for the entire function. So it will be alive until line number 28. So till line number 28, it will be alive. But this, now there is this inner scope, is called block scope. So here, this x is assigned. Now, when you use this printf, this x will be taken, not this x. Okay. Kind of the whatever the shortest scope I can form. So here the shortest scope is this variable. After this, there is this, and the longest scope is like this global. So whatever I can find in short time, I will use it. So this x, so that is how this is used. But if I write this x as 9, then this x will be modified here. So if I write printf here, and then again do printf here, outside from the block scope, you can see the value 9 will be reflected here as well. Yeah, that value 9 is reflected. But if I've not written this thing, then this x is not defined here in this scope. There is not any x. Let's say I've defined like this. Now I want to run this program. Oh, okay. So there is this global. So now it is taking the global variable. So this block scope, the value will be 2, 9, and then this global is taken. But let's say there is no global. Now you will see the compilation. Okay, x is undeclared. Because you have declared x for this block scope, and you have declared the new x with this block scope, and there's a no x here for this. That is why it is giving you. That is all about scope. Any doubt?
But
No,
Yeah.
that int, like if we put it like outside, then why is it getting modified? Like that was 9, that 9 to 299 was coming, right?
Yeah.
Like we only put, like we didn't declare x. Why wasn't
Yeah.
that an error? Like
So you have done like this now. The case was like this, right?
So there was int 9 like in the main itself, but outside the curly.
Okay. So are you saying like this?
Yeah, this one, yes, sir.
This int x is equals to 90, something like this?
Yeah.
Yeah, so let me define it.
Like that 90 was becoming modified into 9, right?
Yes. So I've seen that whatever value you can, whatever the scope that you can find in a sort test kind of thing. So you can think it like this block scope, I can find it instantly. This local, it will take some time, and this global, it will take more time. So accordingly, you can think that, okay, when I've modified this x would be used, not this x or this x, this global x. Okay.
But that x is equal to
But
9.
I've modified. Yeah. So when I've run this x is equals to 9, it will modify this x.
Right. Okay.
So that is why you are seeing that this line number 27 is printing 9.
Yeah.
And it is printing 9, not 78. It is not using global x because there is a local x, and this local x is modified here. Now you will see 299 as an output after running this. Okay.
Yes, sir.
Yeah. So okay. So scope is clear. Now let me cover array. Array is covered, I guess, but let me again revise it. To define an array, you have this prototype. What it will have. You have array of 10 element of type integer. That is how you define an array. So this array can hold 10 integer values. But if you write something like float, then this array can have 10 values which are float. If you write it as a char, then this array will have 10 characters, which is a kind of defining as string. So string is nothing but collection of character. So with using this array concept and character data type, you can have a string. Okay. So you can take, in this case, string only, you can take something like this. So there is a percentage s which will take multiple characters. So to take, you can take like this. And then in case of integer array, int array, let's say 10. If you want to take 10 integer, then you have to write iteration up to 10. I plus plus. Remember, this I will be defined for this scope only. It will not be defined for outer other than this. So this, you can use this scanf percentage %d, and then you pass this address int array I. So this is how you take integer array or float array. In case of float array, you will have percentage %f. For character array, you can take a shorthand here. You can use percentages and array, but you can also have percentage %c here, and then the same thing would go here. The address of that array element.
Sir, percentage C where? In integer
So let's
array?
say, no, for character array. So for character array, I've written this scanf at line number 9 using percentages. You can have multiple, you can scan multiple character. Yeah, you can have multiple character, but if you want to have something like this and you want to scan like individual, then you can have also like this. but it is like more codey, but this thing is like one line. So that is the difference.
Understood.
What will be the execution of line 8 and 9? Line 8 and 9. Okay, so at line number 8, it will declare an array with 10 elements. The size of that array would be 10. And at line number 9, it will take only 10 values and store that thing to the array. If I input QWERTY in the scanf, will it assign every alphabet to element in array? Yes. Yes. So let me write it. So when you do like this, then you write many character, but it will only assign stack smacking detected. Okay, this percentage is the problem here. So it is try to allocate entire thing that I've written to this array. This array size is kind of limited to 10. So the stack is overflowing here. Yeah, you can see the same thing happened here. That is why this this percentage is not secure way of taking a thing. You have seen here the stack is making detected. Why? Because you have more characters. Okay, and since percentages will take everything up to /n, so it will take everything and it will try to assign to that array individually, but you not have that much. The stack boundary of that array is 10. You can only hold 10 elements, so that is why the stack thing is kind of detected. Advanced compiler में हो रहा है, but ये miss भी कर सकते हैं. So that is why this percentages is not used sometime for security reasons. So if you use this, it will nicely have this. Okay, we only assign 10 values to the character. Yes. So this percentage is very dangerous thing. You've seen it. But if you do with 10 element, it will work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. It will work, right? Now we can summon individual alphabet from the array, right? So to get the individual element from the array, you can write the same for loop. Using percentages, you can print a character array, but not for integer and other. So a general way would be to have a for loop. Which will print. So instead of scanf, let me use this printf %c and whatever the value of that array. So in case of value, we pass exactly this array name and then the position that we want to print. So I will go from I equals to 0 to I10 and then I'll print the value here. So I'll print this int array undeclared. Okay. Int array will be undeclared. I will have array. So I've passed. So let me pass exactly 10 values, otherwise they'll be step. You can see the array element exactly same. But if you do this stack stacking, yeah, the program will be done. Okay. Now, since you have got the individual element using this array of I, you can perform any operation that you have seen so far like you can add numbers, you can subtract number, you can perform power of this array element. So let's say I can perform this power of this array element, whatever will be the value, it will be squared. I can perform sqrt, I can perform absolute anything. So array I is just a variable. Treat it as a variable. Okay, so that is how you can take the input, you can print it, and you can manipulate over array. Can we have a variable length of array? Yes, you can have a variable length of array. Let me define that variable length. So we have seen that character array. Let me define a integer array. Okay. Variable length array. So I will write int n. I will take the value of n here and percentage n, and then I can declare an array with that length. It will work. And then I can take input. Let me take input here and print the output. That array I, instead of n, I will go to n. Let me remove all this comment. Okay, so I've scanned integer, and then I'm printing the integer. For scanning, you have to pass the address. For printing, you have to pass the value. Okay. So,
Sir, what will you get if we just print the entire array?
what?
Like printf of array of I is not defined, right? Like array, sorry.
Yeah, what?
Simply
I've not
array.
understood. No. There is no definition like that.
Okay. Yes.
Yeah. See, it's kind of hard way to learn. So let me pass that the number of element in the array is 3. Now let me pass 1, 2, and 3. And let me pass 4 and 5, but it will not be taken. So it is just taking 1, 2, and 3. Okay, let me change the printing behavior. It is very bad here. Let me have it like this. So let's allot an array of size 4. 1, 2, 4, 5, 6, 7, 8. I've entered a lot of value, it will take up to 4. Similar way, you can have an array of 7 element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. And you cannot have just one digit since it is integer, so you can have something like, you can have something like this as well. Okay. So it is just taking up to 7. This is how you can dynamically kind of adjust the size of, you can take the variable number of element in the array. You can take integer. Similar way, you can take float. Similarly, you can take character. So you can take variable length string. But for that, you have to take that variable as a scanner. So that is about array. Okay. This is called 1D array. Why 1D? It grow in one length only. Okay. Any doubt in this array thing? Okay. So this is called 1D array. There is a concept of 2D array as well. So how to define 2D array? Okay. So there is one more thing. You can have a declaration like this as well. Array, something like this. 1, 2, 3, 4. So what it does, the size of array would be computed from here, whatever I've written. So I've written 4 element. So the size of array would be 4. Here, see that I've not passed any integer value here. So the size of array will be implicitly computed with the number of elements that are passed here. So in this case, the size of array would be 4, and the element of those, the 4 element would be 1, 2, 3, 4. I can also have like this, and then in this case, the size of array would be 6. But you can also have like this as well. You can have 100, and then this. So then first 6 element would be this, and then next 96 element would be garbage, or it will be initialized to 0 in modern compiler. Okay. So that is called implicit, and then this is explicit. And then here you can have something like less as well. And then in this case, let me see what will be the output here. In this case, will it throw an error, or will it just scan the array up to that point? Yeah, it is throwing error. So you have declared array size as 3, but you are allotting for 6 elements, so it will throw error. Not just error, this was warning. I've declared array somewhere. Okay, let me remove it. So it is throwing warning for overflow. Yeah, it is throwing warning. You can skip it, but it is better to not have any warning here. Access element in array. Okay, so that is all about array, or 1D array, one dimensional. It is growing in one dimensional. So that is why it is called 1D array. Any confusion, any doubt in this 1D array? No? Okay. Let me cover 2D array. For 2D array, you can write like this. So think it as a it will have 2 number of rows. It's a kind of matrix which is having 2 number of rows and 3 columns. Okay, how to take the input for in this case? In this case, you have to take input as 2, and then in those 2 rows, you will have 3 columns, right? So you will have 3 columns, J++. Now you can take input, and then similarly in printf you have to do it. You have to printf. Yeah, any doubt in this? And how to do it? How to scan it? 2D array like this. So let me tell you the interpretation here. So this array is 2D array. This is a 2D array. You can think it as a matrix where the first thing would be the number of row, and the second thing would be the number of column. So the number of rows is 2, number of column is 3. So I'm iterating the number of rows here, and I'm going column by column. So I'm scanning the array like this. So I will go to first row and I will scan entire column. Then I will go to second row and I will scan entire column. So the scanning is like this only. So this is kind of row by row scanning of this 2D array. So let me do it and then show it. ECC program array element access. Okay, about that access. So there are 2 rows and 3 columns. So 1, 2, 3, 4, 5, 6. You can see I've printed 1, 2, 3, 4, 5, 6. To view it as a kind of matrix, you can print /n for every new row. Now you can see Now you can see the output in a nicer format. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So that is how this 2D array is defined. You can take like this. So it is a row by row. So for every row, I'm taking entire column. You can do the reverse as well. You can declare this 2 and this 3 like this. And then you can exchange this j and I, j and I, j and I. What will happen? Let's see. So it is having 3 number of rows and 2 number of columns. Okay.
It will get an error, right?
Let me see. Okay. This will be 2 and 3. Yeah. No, it should be 3 and 2. The I would be 0, 1. Then yeah. So it is having 3 number of rows and 2 number of columns. Now here I'm doing scanf. Array I is fixed to first column, and I'm varying the row here. Row is varying from 0 to 2. So I'm scanning column by column here. You can see I've changed j with I with j. Previously it was ij. Here I was written, here j was written. So for every row, I was scanning all the columns. Now, since I is fixed here, I is fixed in the sense that this outer for loop is changing the I. So for the inner for loop, this I is fixed. So I is telling you, here the I is telling you the column position. So the column is fixed. Now you are changing the row. So this is kind of column by column scanning. You are scanning the array column by column. Previously, what you were doing? Previously, you were doing like this. So in this case, the I is fixed due to this outer loop. For this inner loop, this I is fixed. So you are scanning all the columns for a particular row. So when you scan all the columns for a particular row, you are doing row by row scanning. But if you write j and I like this, and you have declared the array appropriately, so in that case, this I is fixed here due to this outer for loop. So for inner for loop, this I is fixed. So since you are fixing the column position, the second position is column position, and this first position is row position. So for fixed column position, you are changing the row position. So you are scanning row by row, column by column. So for 0th column or the first column, you are taking all the row element, and then you are printing accordingly. Okay.
Sir, like the naming of the indices of the array starts from 0. Not
0,
from 1.
Yes,
So
it
like
will start from 0.
1 to 2, then less than equal to 2, then that'll give us error.
Yeah, obviously.
Okay.
It will not give error, I guess. This is
Sir,
a kind
should
of
be starting
stack
from
overflow.
1 and equal to 2. Yes, sir.
No, it will not. So in C, the array indices start from 0, not 1. That is the first thing. So if you have an array of size n, you will go from 0 to n minus 1. Because the array indices start from 0, not 1. In C, that is the thing. But if you write 0 to 2, you have exceeded the boundary because you are going from 0, 1, now 2. So it is showing that the array size is 3. But it should not give any error, I guess. But let's see. Because C is not very healthy thing. Yeah, stack is backing detector, you can see. It cannot detect that thing during compilation. But when you try to access it here, see, you have written this ampersand, right? Now you are trying to access some address which you're not kind of having it. So that won't be a valid address for this program. So it is kind of terminated. So that is why this in C, not that is why, like in C, the array indices start from 0, not 1. One more thing, if you print I here, what will happen? In this case, what will happen? Will it throw an error?
What did you do?
Yeah, this I. At line number 20, I'm printing the value of I. The value of I would be 2, then it will break out of the loop, and then you can print the I, and you can see the value of I as 2, right?
Yes.
So will it throw an error, or will it print the value 2? That is the question.
So why will it throw an error?
You tell me. So if for loop, you have declared this for loop, you have not written like this int I here. Okay. You have declared for loop, and this I is kind of scope thing. So maybe inside this for loop, this I is kind of having a scope for this for loop only. If that is the thing, then this line number 20 should give error, right?
Right. Yes, sir.
And if that is not the thing, then line number 20 should not produce any error, and it should print the value 2, right?
Yes.
So let's see what is the behavior not declared, right?
Yes, sir.
So in for loop, when you write this int I, it is an implicit kind of declaration. So it will only lie with this for loop. When you go outside this for loop, this variable is not there. Okay.
Yes, sir.
So the scope thing comes into picture. So any doubt in 1D array, 2D array, function, scope, limits.h?
So is that 3D or like ND array also?
Yes. Similar. There will be 3D array. You can add multiple things here, like this, multiple times.
Oh.
And you can view that you can create n-dimensional coordination system, n-dimensional space, n-dimensional thing in C. Not just in C, but in any programming language, but not in real world. Like the 4D in real term is like very hard to imagine how the 4 dimensions look like. But in C, it is a one-line declaration. This is how 4D look like. Okay.
Yes, sir.
So the interpretation would be a lot more complex here. But in 3D, you can think that okay, let me say. So there would be 3 matrices of size 12 cross 23. You can interpret like this. This when you write array 0 of 12 to 23 of ij, it will point to the first matrix of size 12 cross 23. When you write array 0, when you write array 1, and then whatever value you write here, it will point to the second matrix of size 12 cross 23. And then similarly, when you write 2 there, when you write 2 here, then it will point to the third matrix. And then 4D is complicated, more complicated than this. But you can declare up to any dimension here. Okay. Now here I want to tell you the error that router or the in case of lab you can encounter or you will make. See, I've printed this space blindly. So here, what would be the problem? The problem would be the problem would be you printed this number. Now there would be an extra space, and then again you print like this 3, 4, 5, 6, and there would be extra space. And in the test case, there won't be any extra space. Test case look like this. It will not having any extra space. In that case, your output will mismatch with the test case, and you will get you'll be getting the failed message in that test case. So beware of using this space /n. You can see I've printed the /n like blindly. So in the last line, the /n should not be printed in last row, but it is printing the /n. How to correct it?
Sir, what will
Yeah.
Can you repeat, sir? What error will it show?
Yes. Okay. So there won't be any error like syntactical error, but since the test cases, let's say there is a test case which is giving the output as 1, 2, 3, and there won't be any extra character. But in your program that you have written, if you print it, it will be like this. There is an extra space. So let me write it separately. Let's say you are manipulating 2D array or 1D array, and the expected output was this. That was the expected, but your program is printing like this. You have done everything correct, but your program is printing an extra space. What is happened in Tutor? It is matching the expected output, which is 1 space 2 space 3 nothing, with 1 space 2 space 3, and there is 1 space. So it is matching exactly. It should be the exact match. If it is not exact match, then it will say that your test case is failed. Right? But you have done your computation is correct, your everything is correct, but your printing behavior was like there is this extra space, and due to that test case is failed. Okay. So when you are printing this space or new line, you have to be very careful that you are not printing any extra new line. As you can see in this case, there is an extra new line. Like when you encounter the last row, you are printing one more extra new line, right? You can remove this kind of not bug, but due to Tutor, you can remove it like this. So if I is less than or equals to 1 in this case, then only print this /n, right? So when I is less than, if I is 1, then this /n won't be printed. So extra new line is not printed here. So these things should be taken care while programming on Tutor, because it blindly match whatever the expected output with your output. So if your output is having extra space, extra new line, or uppercase, lowercase, anything like that, then your test case will be failed. So read out the scope, array, limit, function, 2D array, 3D array, 1D array. Okay, let me terminate then today's session. Yeah.
Sir, I came like I think 25 minutes late to the class because I forgot like the iPad put it like the Google Calendar, but then I forgot to like see. So
okay,
sorry.
So I will post in the WhatsApp that after 10 minutes I will be not kind of admitting anyone, because I'm seeing that it is happening repeatedly it is happening. Don't know why it is happening with many students. So I've given like kind of flexibility for you guys to kind of settle up in the campus, but you're still doing the same thing. So next time after 10 minutes, I will not admit anyone in the meeting. Yeah, so be very careful while attending classes. Okay.
Okay, yes, sir. Sorry, sir.
Yeah, okay. So there are only 6 students now. Okay. So any doubt? Should I terminate then?
No, sir.